I want this height where these two bodies will meet. These two balls are thrown simultaneously. Two projectiles are thrown simultaneously from two ends of a distance. This distance I am giving. Okay? Take means this distance is given. Question is you have to find out. If I say the velocity here, this I give you. Let us say this is u, and this is the velocity here is v. This is theta 2. This is theta 1. I would like you to know simultaneously two projectiles have been fired from a distance. Range r is given. Okay. At a distance r. Okay, with different angle. Theta 1 is not equal to theta 2. If theta 1 is equal to theta 2, then this will come exactly in the center. So the velocities you can see, v2 and v1 I don't know, I will not speak, but the angle I tell you theta 2 is more than theta 1. Just I would like to know an expression for this y in terms of all these. Y is the height at which both meet above the ground. If you know the projectile motion properly, you can do that. Okay? You think over this, and we'll have a discussion.
So that is the maximum height attained by both the projectiles.
No. How is it maximum? It cannot be maximum height. If you see this projectile, it can be somewhere here, and it will be somewhere here. So both are shot with different angles, with different velocities, and they cross like this. The trajectories cross at this point. Okay? So this point I would like to know when they. One hint I can give you only. That hint is the time taken by this from here to here through this distance. When this particle reaches here, its coordinates will be this and this. And when this particle reaches here, its coordinate will be x and y this. Time will be same for both. Okay? The time it takes to be from here and here, it will be same. This is like huh?
T is equal everywhere.
It has to be equal. How can this possible? You have fired simultaneously.
Okay.
And when they cross here means the time taken to travel this trajectory means horizontal vertical. By this horizontal vertical, two times are same. So that is a hint for you. I would like you to know the expression for this. You won't get in books में बता रहा हूँ आप देखो अगर दिखता है तो बहुत अच्छा है very now what I just why I told you Dalali ma'am has told that she has done it. All what you have learned about projectile motion, if you know that properly, then you can do that. A little bit you have to do some exercise. Now I'll come to the chapter number 2, that is chemistry. What is the date of it?
26th August.
No, I'm not going to teach you everything written word by word. I'll just ask you number 1. What I have noted there, all of you know about the cathode rays, all of you know about the positive rays, all of you know about this. This I just wanted to tell you because this is one of very, very important. I draw the diagram here. This type of thing is called, you must have seen in the TV inside. If you look at this, it will look like a screen like this. Okay? This is the center actually. I don't need to draw it. Here is the filament which gives out the electrons. Source of electrons. These electrons have to move and strike on this. So these are accelerated through, let us say, it is a positive, and what do we call it? I will make a hole through this. The electrons come and strike somewhere here. I just wanted to give you an idea and take out this screen. Now try to understand the concept because mathematics is not given and you have to do, if you do the mathematics, then you can do all numerical up to 12th and higher also. See, you are not to write anything. Suppose there is a plate. There is a plate and there is a body like electron, his mass is m. Its charge is of course minus, and if this is positive, this is negative. Then of course this will move here. Okay? Let us say the uniform velocity attained inside is V. If mass is m, if energy will be equal to half mv square. Kinetic energy because it is moving. This is the first equation you should know. Now, what has made it to move is the force of attraction by this positive plate. If E is its charge and if electric field intensity E, which is equal to V by L, please note, this is the second equation you should know. That if the voltage between the two plates is V and the distance between them is L, then electric intensity is V by L. Okay? Second equation which you should know, I'll write here so that you know. This is energy. So this is electric field, so I'll add this thing and I'll remove this and write here energy only. Otherwise you will get confused. Equation number 2, that electric intensity is equal to V by L. Simple. 100 volts, 1 meter, 100 volts per meter is the electric intensity. What is electric intensity? Electric intensity is nothing but the force experienced by a unit charge whose value is 1. Okay? It can be 1 coulomb. It can be any other in 1 unit charge. That is called electric intensity. This is equation number 2. I put this in the box. And this is the second equation. So what is happening? Now look at here. Electrons are moving from here to here. There is a potential difference of V between the two. इसके बीच में मैं वोल्ट V लगा देता हूँ. And this is also V. And you can calculate. So electrons are moving from here. They get accelerated and put on this. We have got a fluorescent screen here. So when the electrons strike, fluorescence is caused. There is a spot which you can see in the old TV. When you switch off, the spot was seen. This is the equation number 1. Now, second equation which I would like to give you. Energy is also equal to equation number 3. ये याद रख लीजिएगा for all your time. Its charge into the potential difference. If electronic charge is E, I will not take minus, that gives only the direction of movement. E into V is the electrical resistance. These three equations, if you now combine these three, there is a potential difference V, okay? And you can find out the value of V from here, E into L, okay? This is the energy acquired by electron, which is exactly equal to half mv square. So key equation here is half mv square. इसको आपको भूलना नहीं चाहिए. This is velocity is equal to E into capital V. Never forget this equation. You can do all mathematics with this. Given anything of this, you can solve.
Sir, V is the voltage.
Capital V is the voltage. Voltage means difference of potential between the two electrons or two plates. So this is very, very important equation. From here, if you want to know, you can find E by M from here. See, E by M is how much? How much is E by M?
E by M.
V square over 2V.
2V.
Yeah, again. This is a mathematical part of your structure chemistry which you should know, because that book has not given anything, and this is very important. When electrons are accelerated, they move with some kinetic energy, half mv square. That is equal to E charge of the electron into voltage V. So you can replace V by E into L. If you don't want, you can keep it like this only. So basically this equation can be used from here only to find the value of E by M. Take V here, V square for 2V. But here you do not know V. You do not know V, what is velocity. That now I am going to the second part, which is very important. Now, this is the first part, mathematics of this much area. Okay? Now mathematics, next part. How to find V? I don't know whether you understand or not. Suppose I do like this and put it like this. And one plate here, this is negatively, this is positive plate, and something, a hole in this anode. Potential is between these two. This is just a disk to make the electron hole move. electron particles move through the hole. If everything is okay, they will strike in the center. If suppose now I apply an electric field here like this.
Towards the positive charge.
Yes. This also, no, I forget about this. This positiveness is used to accelerate, give some velocity to the electron, so I remove it. This electric field is used to deflect. The electrons as they move here will move towards the positive plate, and they will, if it is extremely high, they will go there. But we don't make like this. They move like this and they strike here. So this part is shifted here through some distance. This has shifted from here to here due to force of electric field. So I vector F in. If you apply magnetic field like this, suppose electron is moving like this. Now we are not going to this one. Forget. Mathematics is reading on this. Electron is moving. You apply a positive potential, negative potential. Electron will go up and strike here. To bring this back, I apply a magnetic field perpendicular. When you apply a perpendicular magnetic field and electron is passing through this, direction of magnetic field can be from here. If this is north pole, this is south pole, magnetic field is like this. If this is north pole, this is south pole, magnetic field is like this. We'll check what is it. Electron is moving in this direction. Magnetic field is like this. Force will act on this. That is given by Levin's left hand rule. If you remember that. And that force is equal to VQB. Now you take, now I cannot draw. They have shown the diagram like a magnet like this. So you have to place one plate here, other north pole. One pole here, other pole. So it can be something like this, which book has shown. So what is the meaning? Meaning is that we apply electric field and magnetic field in such a way. First we apply electric field. Only it gets shifted from here to here. Now I apply magnetic field, which is exactly equal to this. Force due to magnetic field V. Both are equal. That will bring it down. If you apply only magnetic field, what will happen? No electric field applied. The spot will go down. Apply electric field, it will bring it down. Both ways. If the two forces are equal and opposite, you choose the value in such a way that the spot remains undeflected with the application of magnetic and electric field. Then this equation holds. This is one of the very important equations which we are using in this region. That is, force due to electric field is equal to the force due to magnetic field. And if E is a charge, the force in electric field is always equal to what? E into?
Force in electric field.
E into capital E. E into capital V. Charge into voltage is energy. Please remember. Electric field into charge is force. This is the force acting on one charge, and force acting on each charge will be into this. Capital E is the force acting on a unit charge. One charge, one coulomb charge. So E is 1.6 into 10 to the power minus 9 coulombs. So how much force will act? So this is the force due to this electric field which pushes it up, and this is exactly equal to VQV. E into V into V. From here you can see E and E cancel. So velocity is equal to E by V. This is for numerical. Simple. An application of this much of electric field produces shift of the electron, which is brought by a magnetic field of value B. What is the velocity of the electron? Then not saying we do not know. Ratio of electric field to magnetic field is always equal to velocity. If this electric field is of electromagnetic wave and B is also of electromagnetic wave, then E by V is always equal to C, velocity of the light. That is also there. That is how we take it. So now you will put this value of V in the first equation. So what is the key equation? Number one. In this is in Thomson's model. What is this model? This is Thomson's model. What is in this? What is the concept? It's used to find what? E by N. Number one. How do you find E by N? First we equate in the first half two energies. Half mv square is equal to E into capital V, and find E by N. But there is the velocity small v. Voltage can be measured, you cannot measure the velocity of the electron. So what we do, in order to find the velocity of the electron, we take the second part where we subject the electron to the two equal and opposite forces due to electric and magnetic field. They have to be kept perpendicularly. Otherwise, if you have to use the rule and check it. So when you shift this spot from here to here due to electric field, bring it back by applying magnetic field back. So electric force on the electron bunch. Every second electron is coming millisecond. So we are talking of the entire one electron goes, second goes, third goes. So we are talking of all the electrons. And we assume that all the electrons are moving in the same velocity, which is not possible. But small v half mv square is the energy of, we have taken one electron. Okay? So half mv square is equal to E into capital V. From there we found that E by m is how much? E by m. What was the equation written? E by m. Huh?
V square by 2.
V square means what V?
Sir, V small v, that is the velocity.
But you replace the small v by E square by V square. So everything is now known to you. Okay? Three things are known. So you can find E by m. This was done by Rutherford to find the value of E by m. After that came Millikan. He found the value of E only. So E by m. If you divide E by Millikan's oil, divide by EM found by this method, you will get m mass. So you know how to find the value of E, or how to find the value of m. M you cannot find by any other method, which is a direct method. You have to use these methods. So second point I want to, so mathematics of this you should know. I have given you the E equations, and all this is in class 12 physics. So simultaneously now you are doing class 12 physics also. I wanted to tell you because you people are doing higher mathematics. You are doing studies for higher exams. So you should know these things. Okay? Now, very simple. Similarly, Millikan's oil law technique. And I will explain you what is the mathematics of that. Because questions can come on that, numericals can come on that.